Hey guys, good morning. Today I'm going to be giving a workshop on recursion in JavaScript. Okay, and I'm going to give a few basic examples of using recursion, and I'm going to explain how you can use recursion in your code. But first, I want to ask, who values clean code, right? Everybody values clean, elegant code, and recursion is one of the most elegant features of JavaScript, I would say. It looks simple, it looks beautiful, and it can be powerful. Okay. So with that introduction, let's ask ourselves, what is recursion? Okay. A recursive function is a function that invokes itself. And each time it invokes itself, it slightly modifies the input. And it will continue to modify the input until a certain condition is met. And when that condition is met, it's going to break the loop. Okay. So if this sounds a little bit confusing, let's code a little example, a very basic recursive function. So I'm going to have a function called add previous, and it's going to take a number as its argument. Okay. And what this function is going to do is it's going to take the number and it's going to add that number and all the previous numbers between that number and 0 to get a total. So let's say our number is 5 as the input. We're going to get 5 plus 4 plus 3 plus 2 plus 1. Okay, and that should equal 15. But let's test it for ourselves. So how would we code this in recursion? Firstly, we want to check if number equals to 1, return 1. Okay. This is called the base case. I'm going to explain a little bit more about that in a moment. So if number equals to 1, return 1. Else, return number plus add previous. And you see we are invoking this function within itself, but we're going to slightly modify the input. So we're going to say number minus 1. Okay. And what is this going to do? Every time it invokes itself, it's got a slightly different input. So let's say we want to use our function and we want to test it with add previous of 3. Okay. So let's go through step by step what's going to happen. Firstly, we're going to call add previous 3. So we're going to check if 3 equals 1. Well, no, that's false. So we're going to go down to the next line. Return 3 plus add previous. See, it's invoking itself 3 minus 1. And 3 minus 1, we can simply put 2. So now we have add previous 2. But we don't know what add previous 2 is, because we need to calculate it again. So we'll go down and we'll do the same again. Add previous 2 is going to return, it's going to check, is 2 equals 1? No, that's false. So we'll go to the next line, return number, so 2, plus add previous of 2 minus 1. And we can simply do add previous of 1. Well, what's happening? We're still waiting on a response here. Okay, so we haven't got our final answer just yet, but this recursion is what's happening when the function is invoking itself. So finally, we'll have add previous 1, so one more line, and that's going to return, well, what's it going to return? Add previous of 1, we check. If number equals 1, return 1. Okay, so we just put 1 in like that. Now, these functions are stacking on top of each other. Okay, and in recursion, this is called the call stack. The call stack, and it's kind of, I'm not going to go into detail about what the call stack is. That would require another workshop. But it's essentially a queue of functions where the last function called is the first function executed. So this was the last function called, and it's going to be the first one executed. So we stack down like that, and then it goes back up. Okay, so now we can get our answer, return 1. So return 1, we know what this is. This, we can just put 1, and we can remove this line here. Add previous to, well, return 3. So we can remove this line here and put 3 in, like that. And then we know 3 plus 3, we can just put 6. But why don't we test our function? We can test our function in VS Code. We can run it. So add previous of 3, and I'm just going to console log that. And here we go. We've got the answer right here, 6. And we can test that with whatever other numbers we want. Add previous of 4 should be 10. Let's try it out. 10. Add previous of 5 is going to be 15. There we go, 15. So we know it's all working beautifully. Now, a little bonus information for you guys. A moment ago, I showed you that call stack, that recursive functions stacking on top of one another. Now, when you have no base case, no condition to break this recursive loop, that function, add previous, will continue invoking itself with different inputs forever. And what you end up with is a recursive version of an infinite loop. We call it a recursive loop, but it's also known as stack overflow. So the phrase stack overflow, it comes from recursion, in case you didn't know. So how do we prevent stack overflow from occurring? We have to ensure that our recursive function always trends towards the base case. Okay, so here we start with the number 5, and it's going to go down, down, down until our number equals 1, at which point the loop is broken and we can return our answer. Okay, so does anybody have any questions so far? All good. All good, all good. Okay. So the syntax, this may seem a little bit complicated. So I'm going to touch more on the syntax of our recursive function. Here, this is called the base case. And down here, it's called the recursive case. I've written this code again down here, kind of in English, kind of English code, mixed together with words. So if condition, return answer, else invoke the function with a different input. Okay, but we don't need this. We don't really need to look at that for the moment. Now you might be asking, right, well, recursion looks nice, but surely I can just do exactly the same function with a loop. Surely we can just use a loop to do exactly the same thing. So let's compare this recursive function with the same function in a loop. All right, here we have exactly the same function, add previous, using a for loop. So we have our base case here, and it's going to loop through, and it's going to give us the same result. Now, this is a very, very simple example. We're just getting the numbers from 1 to 5, from 1 to our target number. But personally, I think the recursive function, it looks a bit more elegant. It looks a bit more readable. Now, at a level as simple as this, it's hard to see the benefits. For loops are easy when they're this simple. But imagine you're working on a big project. Those loops can get very complex. They can get very messy. So you would like to make your code more as readable and elegant as possible. And that's where you really harness the power of recursive functions. Okay, so normally on a larger scale, if you can use recursion, you really feel the benefits of recursion. So recursion looks cool, it looks elegant. How to use it in a real world example? Let me show you guys an example where I recently had to use recursion for some real coding. So recently I built a calculator using pure JavaScript. And what the user does is they type in the values that they want to calculate. So 1 plus 85 divided by 17. These are just a random set of values. It could be whatever the user wants to calculate. And part of the mathematics inside the calculator, I wanted it to operate like a real calculator would. So first, process the divide symbols and the multiply symbols, and then later on we can process the add and subtract symbols. So what's going to happen? First, we're going to put our array as the equation inside this process, and it's going to process the multiply and divide symbols first. Now, how's it going to work? First, we're going to check, does our array contain multiply or divide symbols? Okay, and if it doesn't contain any, then this condition is met and we can stop the recursive function. So what are we going to do? We're going to check, does it not contain multiply or divide? Well, this is false because you can see we have a divide symbol, we have a multiply symbol. So what's it going to do? It's going to continue onto the code. Now, I have substituted out the real code for this function. It's down here. You don't need to know exactly how this code works, but what it's going to do is going to find a multiply or divide operator. It's going to take the values either side of it, and it's going to calculate. It's going to pull them out, perform that calculation, and slot them back into the array. So 85 divided by 17, it takes it out, performs that calculation, and it's going to put back in 5. Okay, and then we'll go down, and our function is going to call itself again. You see here, process multiply and divide, and thanks to VS Code highlighting the same function name, we're calling ourselves, but we're calling it with a slightly modified input. We're using our slightly modified array. Okay, so what's it going to do? It's going to start again. It's going to check, does our array contain a multiply or divide symbol? Well, that's true because we have a multiply symbol here. So it's going to jump to the next line. It's going to perform this operation. And then it's going to invoke itself again. So one final time, we check, are there no more multiply or divide symbols? That's false. So we're going to perform this calculation. And we're going to invoke ourselves one final time with this modified input. Back to the top. Does our array contain no more multiply or divide symbols? True. Okay, we've processed all of the symbols and now we just have a plus, and we can do that in a later function. Okay, so now we're going to return equation. And this is a real world example of where you might use recursion. Now, I could have done this using a loop. In fact, I did code this same function using a loop and it was successful, but I promise you guys it was very, very messy and it was much less readable than this very nice, simple, elegant function right here. So, recursion sounds great, looks great. You might be asking, are there any disadvantages to using recursion? And yes, there are a couple of disadvantages. The first one is that it uses memory, okay? Because when we are building up that call stack, in that example I showed you down here, when the function was stacking upon itself, that uses up some memory. And the second disadvantage is that for this reason, recursion can be slow, okay? You have a function that's calling itself repeatedly, and this can be slow. So if you must prioritize speed in your application, then I would suggest using a loop, okay? But for readability and elegance, you should try and use recursion. It's going to make your coding journey a lot easier. So, quick final recap. We have our base case, and this is the condition that will break the recursive function. Now, this could be anything. I've used number equals 1. We could have if number greater than 100. And our recursive call could be number times 5 minus 3. It can be anything, okay? Anything. As long as this modified input trends towards the base case. Okay. Else, if this condition is never met, you're going to have that recursive loop. So thank you guys for listening, and I appreciate you guys watching my workshop.